Hello, and welcome to another episode of the AWS Study Series, streaming right live on YouTube. My name is Motunrayo Sanusi, and today, whether you're a cloud newbie, a seasoned engineer, or you're just here to soak in tech vibes, trust me, you're in the right place and you have picked a great day to join us. Please, if you can hear me please drop an emoji in the comment section. Okay, I can see Abimbola from Jamaica. Okay, so this is a quick reminder for those people watching us. This is YouTube Live, so you don't need to worry about your mics. Just sit back, relax, and enjoy. But please don't be silent. You can jump into the chat. You can also let us know where you're joining from, and feel free to drop your question as we go, so we'll be able to catch them during the Q&A section. Thank you. So please keep dropping where you're joining from. I can only see Abimbola from Jamaica. Is that the only person we have here? Oh, thank you, Abimbola. So let's just get right into it. So today's session is titled Guardrails in Code, Enforcing AWS Compliance at Scale with Cloud Custodian. Yeah. So in today's world of cloud chaos, misconfiguration, and policy ethics, how do we make sure that our AWS environment stay compliant, not just once, but consistently and automatically? And this is where Cloud Custodian comes in. The policy as code tool that brings structure to madness, and guiding us through this session today is none other than our guest speaker. Please drop an emoji in the chat box before I bring it in. Let's see. Are we active? Okay. We have David from Nairobi. Good evening from Lagos, from Kutsi, Israel. Nice. Thank you, Israel. Thank you. So it is with absolute pleasure to introduce somebody who is not just an expert, but also someone I deeply respect. Oreoluwa Jetawo is a security engineer and cloud architect with over 3 years experience in building and securing enterprise infrastructure. He has led multi-cloud security programs that have slashed cloud costs by 50% and has mastered everything from threat modeling to penetration testing and scaling DevSecOps across organizations. But beyond the titles and credentials, Oreoluwa was my coach, and to this day, he's still a mentor to me. So getting to introduce him today is more than just moderating. It is an honor and a full cycle moment I'm truly grateful for. So please, let's give a warm virtual round of applause for the brilliant and inspiring Oreoluwa. Over to you, my boss.
Yeah, thank you, Motunrayo. Thank you for that exquisite introduction. But yeah, I've not mastered everything, right? There's still room for improvement. There's a lot of room for improvement, right? So
Yes.
I'm guessing I can start, right?
Yes, you can start. Go ahead.
All right, thank you. So let's just let me know when you can see my screen. Right, so let me know when you can see my screen. All right, I think it's sharing, and so let me start. All right, perfect. So today we'll be talking about enforcing AWS compliance at Cloud Custodian. Um, so I think first of all, I'd just like us to talk about compliance, right? What does compliance mean, right, from a security point of view, right? And or what does cloud compliance mean, right? So cloud compliance is just ensuring that cloud-based systems, applications in the cloud, right, and infrastructure, you want to ensure that they adhere to certain regulatory standards, right? So basically just implementing policies, practices, and just technical controls, right? Just to ensure that your cloud environment is aligned with existing principles and standards, right? And so the problem we're trying to solve is compliance challenges, right? So we have various compliance challenges, right? We have data privacy and protection. We have how effective are these security controls that you implement in the cloud, right? Challenges of the shared security model, or rather shared responsibility model. So we know how security is a shared responsibility model, how the provider takes care of the security of the cloud and you take care of the security in the cloud, right? And at times there's a very, very gray line in sense of what aspects of security am I supposed to take care of, and what aspect of security is AWS or Azure or GCP supposed to take care of, right? Then the next is data sovereignty and localization, monitoring compliance and reporting. So for the sake of this demo, we'll be focusing on two compliance challenges, right? Which is what I highlighted here: the effectiveness of implementing security controls in the cloud, and also monitoring compliance. So there's something we need to note, right? There's something we need to know that when you want to maintain compliance at scale, right? If you don't attempt to automate it, right, then it becomes nearly impossible, right? Most of the cloud breaches that we see, right, it's as a result of a single misconfiguration, right? Something as simple as um, a publicly exposed bucket, right? Hosting, rather, this bucket has like credentials of your entire organization, right? So this brings us to the topic of the day, which is Cloud Custodian. So what exactly is Cloud Custodian? Cloud Custodian is an open source, a very powerful policy as code rule engine, right? So it designs for CSPs and also Kubernetes clusters. So when I mean CSPs, I mean your AWS accounts. I'm talking about your Azure subscriptions. I'm talking about your OCI tenancies. I'm talking about your GCP projects, but and also Kubernetes clusters as well. So it's about what it does is it helps you to enforce security and compliance across your entire organization, right? So the main purpose of using Cloud Custodian, you want to reduce that manual effort to the least possible way. Right? Remember earlier on, I said that if you want to try and um, enforce compliance at scale, and you are trying to do that manually, right, it's nearly impossible. So Cloud Custodian brings that autonomous process into place, right? So it just helps you to collate all your multiple script and tools into one unified framework, right? That's what Cloud Custodian does. And how does Cloud Custodian work in AWS, right? So first things first is what it does is policies are deployed as Lambda functions, right? So Lambda functions are serverless AWS services, right? That is used to automate certain process, right? So and due to the fact that you have Lambda function, right? So you can trigger Lambda function, right, to enable real-time responses to resource changes, right? And event integration. So you have a Lambda function, and a Lambda function has to be triggered by something, right? So is your Lambda function triggered by an event? So when I mean an event, let's say probably someone decides to disable encryption for particular buckets, or someone tries to create a, let's say, an EC2 instance that the EBS volume is not encrypted, or someone tries to disable versioning for a particular bucket, right? So aside that, so that falls under event integration, right? Where your Lambda function has to be triggered by a particular event. And last but not the least, reporting. So what happens is you can push all those logs to let's say next bucket or so. So now an event where you want to track what's going on, and even CloudWatch logs as well, right? You want to see what your Lambda function did. You want to see the resources that your Lambda function remediated and all those kind of stuff, right? So it's very, very good for a multi-account kind of structure. So the next is how do you write a cloud custodian policy, right? First things first is cloud custodian policies are written in YAML format, right? And they include three important sections, right? You have your resource, you have your filters, and you have your actions, right? So this makes it very, very readable, right? So you can look at the policy and you can see what this policy is trying to do, right? So if we talk about the resource now, right? Remember earlier on I said that cloud custodian works across multi-cloud architectures, right? Multi-cloud providers. So You're talking about things like your S2, you're talking about things like your ECR, your SD buckets. Literally, as long as it's a resource in the cloud, right? Then next thing you want to do is for filtering, right? Your filters. So what exactly is filter? Just like the name implies, filter. So you're trying to select a particular resource, a particular group of resources, right? So take for instance, let's say you want to filter for an SD bucket that is tagged as this. I want to filter for an SD bucket that has versioning disabled. I want to filter for an SQL skill that doesn't have encryption enabled, right? Or I want to filter for security groups that have port 20 open to any, or you want to filter for a database that is publicly accessible. So literally anything, right? Even if you want to filter for resources that have been turned on for a very, very long time or spun up for a very, very long time. So think about how you can filter for resources that have been forgotten, right? Because we all know that when you when you implement that kind of multi-account strategy, right, and you're utilizing more than one region, then it's definitely possible that there's a particular resource in a particular region that you've completely forgotten about, right? And those kind of things are very, very those kind of forgotten resources, right, are likely to be a part for an attacker. So I mentioned something about automating at scale, right? And definitely you might be thinking, oh, that cloud custodian only works for per account structure, right? I have one account, I'll deploy to one account at once, or I'll deploy to one Azure subscription at once. But no, right? Cloud custodian enables you to deploy a policy across multiple accounts at once with a single line of code, right? So this helps to bring that structure into place, and it also helps you to integrate your CI/CD pipeline. So take for instance, and let's say you have your policies in GitHub, or you have your policies in, let's say, Bitbucket, or you have your policies in GitLab, right? Then you can make adjustments to those policies, right? And when you do that, you have a GitHub Actions workflow, or let's say if you are using code pipeline now, right? You have a stage that basically compiles the code and runs that command. So I think I'll be going to the demo so that we don't talk too much and forget why we're here. So let's go straight to the demo. So one sec. So let me know when you can see my screen. All right. Okay. So for the sake of today, all right, we'll be working with five policies. So I've created five policies here, each offering different kinds of things, right, triggered by different kinds of events. So just like you can see here, right, this what this policy is supposed to do is, or rather, the name of this policy is enable bucket login, right? And you can see the resource they specified as ST buckets. So this is just a description, right? And you have your mode. So what this mode does is, how frequently do you want your this policy to run, right? So we have periodic here, and it says rate 2 minutes. So this just means that, okay, that you want your Lambda function to run every 2 minutes, or you want a Lambda function to get triggered every 2 minutes, right? And you have what you call a rule here, cloud custodian rule. So you might ask me then, what exactly does this rule do? Every Lambda function needs an execution rule. Execution rule in terms of when this Lambda function is triggered, what is it supposed to do? Right? What resources does it have access to? Right? That kind of stuff. Then you have your filters, right? So if you look here, you can see that I'm filtering for ST buckets that are created in this null region. So you might ask me that why am I using null? So in Cloud Custodian, US is to is defaulted to null, right? But in an event where you are dealing with other regions, then you can definitely change this null to, let's say, something like US is 2 or US was 2 or whatever, whatever, right? But the main purpose here is you want to check for bucket log if bucket logging is disabled, right? So you can see here that we're creating a Lambda function that gets triggered every 2 minutes. The Lambda function is assuming the cloud custodian role and is looking for buckets in US is one null region, right, where the bucket logging is disabled, right? And you have the actions. So after it filters for this particular resource or for these resources, what do you want Lambda function to do? Right? You want your Lambda function to toggle login. And definitely when you mean you want to toggle login, right? You want to enable access login for these ST buckets, then you need a target bucket, right? If someone tries to access this bucket, right, you need those logs to push into another bucket, right? So that's what we have here, a target bucket, then you have your demo access logs, etc, etc. And we have a prefix, right? So it is best practice that when you're trying to create buckets or when you're trying to put in order to a bucket, you use prefix, right? It's faster to retrieve. Then we have another policy, right? What this policy does is to enable versioning, right? ST version. So what does versioning mean? Right? You know, there are instances where you might mistakenly delete a bucket, right? So versioning ensures that when you delete a bucket, you can still so rather when you delete an object from a bucket, right, you can still retrieve that object from that bucket, right? So what it does is it creates a marker, right? So a marker is like a point, right, of an existence of your particular object, right? So when you need to retrieve that object, all you need to do is to retrieve the marker, right, and your object comes back. So but then your object goes away completely if you decide to delete the marker, right? So what this does is just like I said, right, this is periodic, right? So periodic is event bridge, right? So there's a service in AWS called Event Bridge. So what it does is it helps to trigger certain processes at certain like a cron job or so, right? So periodic is for event bridge. So you're trying to create a Lambda function, right, that gets triggered every 2 minutes. A Lambda function is going to assume the cloud custodian role, right, and is looking for basically, if you notice, I didn't filter for any region here, right? So it's looking for every bucket, right, where the version, I have the or statement, meaning that it's either this or this. So I'm filtering for buckets where the versioning is suspended or there's no versioning at all. And after it filters for these sets of buckets, right, what do I want it to do? Right, what it does is I want you to toggle versioning, right? So that's the second policy. Then the next policy is to enable VPC flow logs. So why is it even important to enable VPC flow logs, right? There are instances where traffic in and out of a VPC, right? How can you monitor that kind of traffic? It's through your VPC flow logs. And mind you, guard duty uses VPC flow logs as an event source. And what is guard duty? Guard is an AWS threat intelligence tool, right, that helps you to look at your accounts, look at activities within your account for malicious or anomalous activities, right? And same thing as your filtering, if the flow logs for the VPC is false, I mean, if it doesn't have any flow logs enabled, the mode is periodic, right? And that's a Lambda function that gets triggered every 2 minutes. That's in the cloud custodian rule. And what do you want to do? You want to do set flow logs, right? And definitely there are different when you enable flow logs, right? There are different destinations. You can either update or push those logs to an SD bucket or to CloudWatch, right? It's left to you. More for this demo, we're going to push our logs to S3, right? Then we have another policy. What does this policy do? So basically, this policy is related to EC2 instances. So if you notice here, our mode has changed from periodic to CloudTrail, right? So this means that we want to filter for a particular event, right? An event here is run instance. This means that whenever you try to create an EC2 instance, right? That's a run instances, right? So whenever want to create an instance, right? This Lambda function is going to get triggered. And what is it filtering for? It's filtering for if the EBS volume that attached to this instance is not encrypted, right? You want to terminate that kind of instance. And take note that it really doesn't matter how these resources were created, right? If they were created using the ClickOps method, or if they were created using yeah, your IEC, whether you're using Terraform or Pulumi or AWS CDK, or CloudFormation, it doesn't matter, or it doesn't regard any operation, right? As long as it filters for that resource, right, and it matches that filtering, it's going to perform whatever action you tell it to perform, right? And last but not the least is unencrypted SQS. So what this Lambda function, or rather what this policy does is the mode is periodic, right? So that means that it's a Lambda function that gets triggered um based on schedule, right? So it gets triggered every 2 minutes. And what is it filtering for? It's filtering for if you have a, let's say, a queue that has encryption disabled, or there's no encryption at all. But I want, what you want to do, you want to set the encryption, right, using the default AWS keys for SQS. So yes, so but you might ask me that how did I get this information and all, right? How did I know what filter to use? How do I know what action to use? Or how do I know for this particular resource, right? What kind of modes are available for for this kind of resource? What kind of actions are available for this kind of resource? So ideally, right, this is the documentation page for Cloud Custodian, right? So you want to, yes, imagine now that we're doing AWS, right? All you have to do, go to AWS, then under AWS reference, right, you go to the execution mode, right? So you can see here that you have different execution modes, right? You have schedule, pull, periodic, hop find. So hop finding is when you want to trigger that policy, right, based on the security hub finding, right? Guard duty is when you want to trigger that particular policy based on the guard duty finding, right? Config rule is where you want to trigger in this policy based on the config rule finding, right? And it's so this just means that you can definitely integrate your cloud custodian policies with config, right? Ideally, right, you might ask me that, oh yes, but I can do this entirely with config. Yes, but config will not help you to automatically remediate those um, resources that are not compliant, right? And but ideally, how do you remediate those resources, right? Is by creating Lambda functions. That means that you need to sit down and start writing Lambda functions from top to bottom. But instead of actually writing those Lambda functions yourself, right, you have an open source tool that can help you to write those Lambda functions, right? All you have to do is just create a very readable YAML policy code, right? That tells you, okay, this is what I want to do, this is what I'm looking for. And it is also very, 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 very easy to integrate this with your IAC template. So let's say you have a standard, the essence of having a template is to have a standard structure across deployments, right? So you know that, okay, that when you're creating an S3 bucket, that the bucket within your template, right, you have ensured that encryption, you have enabled versioning, you have enabled access logging. But what if something happens somewhere and someone tries to disable versioning, right? Right. So you can create policies based off of your IEC templates, right? Just to ensure compliance. Then then under actions, right? So you have different kinds of actions, but let's move to resources, right? So you have action and filters based off of resources, right? So if we take, let's say, let's pick a sample resource, for example, let's say S3 resources now, right? And if you go to filters for S3, right, you can see that we have countless number of filters there. So you can filter for an S3 buckets, and you can filter for bucket encryption, bucket login, if the block public access is enabled, or if cross account replication is enabled on the buckets. So literally anything, right? You can also filter for a value as well. So there are instances where you might not see what you're filtering for, All you have to do is to filter for a value. So as long as you can get the properties of that particular resource, right, then you can filter for the value. Then the next is your actions, right? After you have filtered for this particular resource, what actions can you take? Right? You can tag a resource, you can encrypt the buckets, you can invoke a Lambda function, right? You can toggle versioning, toggle login, you can set bucket versioning, you can even remove an S bucket from statically hosting a website. So so it's literally, you can literally do anything, right? As long as you know what you want to do, right? And there's a very very large community for cloud custodians. So you can, if you definitely have any questions, right, or even if you want to improve the tool, right, you can always raise a pull request and all. So let's get right into business. Yeah. So first of all, how do we even, if we want to start custodian, or if you want to deploy this policy, what do we do? So under, let's go to introduction. So we all know that documentation is very very important, right? The saying things that you might not know off the top of your head, so you just want to have a documentation at your fingertip. So first and foremost, right, since I'm using a Windows machine, right, first things first is you want to so you can really ignore this part of the command and just install Cloud Custodian. So what this does, it just create a virtual environment for you to install Cloud Custodian, but we don't want to do that. So we just want to install Cloud Custodian directly, right? So take note that if you want to implement this for any other cloud providers, right, you have to add um a suffix after, right? So if you see a C7N Azure, so you might be asking me what's C7N. So C7N is short form for Cloud Custodian, right? C7N. So you have for GCP, you have for OCI, right? So I already have my I already have Cloud Custodian enabled already, or rather installed already, so I won't install it again. So if you want to run Cloud Custodian like based on an account level, account by account, right? All you have to do is to click to run Cloud Custodian. But we want to go ahead and implement Cloud Custodian from an organization perspective, right? We want to roll out Cloud Custodian across multiple accounts and even across multiple regions, right? So the first you need to do is you need to understand what accounts, right? What organizational units do you want to deploy your Cloud Custodian to, right? And we have been provided with a Python script. So what this Python script does is it looks through your AWS environment, right? So it uses AWS's organization API. So what it does is it looks at your organization, it looks at all the accounts within your organization, right? And it fishes for all the accounts, right? So it helps you to find the account name, the email address, right? And even different rules and all, right? So let us run the orgs accounts.py. So you can also decide, oh, that you don't want these policies, or rather you don't want to run these policies across multiple accounts, right? You just want to run it for a couple of accounts, or you want to exclude an account, right? So if you look at this I flag to ignore, right? So once you have this I flag, right, and you have an account ID, this means that okay, that you want to completely ignore this account. So for this demo, we are going to ignore our management account. So let's try to generate our accounts folder, right? So let me let's try and generate this. Okay. um, all right. All right. So what we're going to do is we're going to run our orgs.py. So there are different. You have these org accounts.py is for AWS. You have one for GCP. You have one for Azure, and you have one for OCI. So for us to run this Python command, right? It's Python orgs account.py. Then you want your output, right? but it's not going to work because we need to be authenticated to our AWS environments, right? So let us first authenticate. So let me do that shortly. All right, do that shortly. All right, so export AWS profile, master. All right, so all right, view other app. Okay, great. So let's just test, right? So AWS S3 LS. Let's see if we authenticate to our AWS environment. Just test. Great. So we are authenticated to our AWS environment already, right? Then the next step for us to do is to run our Python script that helps to generate our accounts. Accounts. So this could be any name, right? So this is just the output. So F output. So yeah, what? So the findings. Where do you want to upload those findings to? Right. So let's do this, or rather, right? I said I was going to exclude the master accounts, but I didn't do that. So let's take a back step slightly. And all right. All right. So let's delete this, what we generated, delete, and let's run it again. Right. So we have a I. Remember, we said I is to ignore, right? So we're ignoring our root account or our management account. So, okay. So you can see here that it looked for the credentials in the default AWS credential files, right? And it generates the accounts for you, right? So you can see here that you have the account ID, the display name, the email address, the org ID, the role that your custodian is going to assume, right? So you already that's the first step of what you want to do, right? You need to understand, okay, what account am I deploying cloud custodian to and all. And then the next step you need to know is you need to understand your policies. You need to know, am I going to create an NST, or rather will this policy require an NST bucket, or will this policy require something, or will this policy require a rule, right? So take note that this policy is going to require cloud custodian, right? And this policy is also going to require access login buckets, which we don't have, which we are going to create. So we're going to create two things, right? So we already have a cloud formation template, and what this does is it creates our cloud custodian role for us, right? So you can see here that I gave my cloud custodian the least amount of privileges, right? So take for instance, we know our cloud custodian is going to do something relating to S3, right? Get object pull buckets. Our cloud custodian is going to create a flow log, right? We did that as well. So when I mean cloud, because I'm talking about Lambda function. I know, okay, that your Lambda function is going to enable encryption, is going to terminate instances. So I could easily have given my Lambda function full admin access, but that means that I'm not doing what I'm preaching, right? You have to ensure that you give this particular rule the least amount of privileges, right? And if you look at my trust policy, I can say that only a Lambda function can assume this policy, or rather, only a Lambda function can assume this rule, right? Then we also have another template, right? So what this template does is it creates your access login bucket, right? You can see here that I've created um, a space for the account ID. So it dynamically fetches the account ID, it dynamically fetches the region as well, right? So we have a access login bucket, right? Encryption is enabled by default, right? If you see, I didn't enable versioning, All right, so definitely when we run our policy, right, we should expect these buckets to have versioning enabled. We should expect this bucket as well to also have versioning enabled, right? And also access logging enabled as well. Then um I also created another bucket, or rather I'll create another bucket. But for the sake of this demo, I won't need to create these buckets, right? So what exactly is this bucket supposed to do? So it's just like an output, right? Imagine if you want to know, okay, that these are the resources that are affected by Cloud Custodian, right? You can push those logs to a particular bucket. For the sake of the demo, I'm going to push those logs to my endpoint so you can see what those logs look like. All right. So let's first of all, the first thing we are going to do is actually to create our resources, to create our demo environments, right? And since we are dealing with um multi-account structure, we're going to use something called cloud formation stack sets. So cloud formation stack sets helps you to deploy resources at scale across your environment, across your accounts, right? So you might want to deploy, let's say, a role to every account in your organization, but you don't want to deploy them one by one. So that's what cloud formation stack sets helps you to do, right? So let's use stack sets for deploying those resources. So let's go to our cloud formation. All right, so under go to stack sets and we'll create a new stack set. So we leave everything as default, right? We are uploading a template file, so we're going to choose a template. And so let's wait for the drag and drop. All right, great. So we have our downloads, AWS. Oops, that was a mistake. It's not going to work. I uploaded a PPT, so let me just cancel that right away. So create a stack set, upload a template file, choose file. Yes, downloads, then AWS demo. So we want to create our role first. So open. So take note when you create a stack set, right? It doesn't apply to your management account. So this means that the role is really going to get created in your member accounts, right? So next, I'm going to give our stack set a name. So let's say custodian role, right? We don't need any description. Then next, then leave everything default. Acknowledge. Next, then yes. So you can deploy your stack set to the entire organization, or you can deploy to a particular OU. So when you talk about organization units, that means like a collection of accounts. So you can have an OU for the finance team, or you can have an OU for your security team, right? You can have a production OU, you can have a dev OU, you can have a staging OU, right? So yeah, so when we know that AWS resources could be globally available or they could be region specific, but identity access management is an example of a globally available resource. So that means that you cannot deploy an IAM rule or a user or a group or a policy. You can only deploy it to just one region and it's available across your entire organization. Right. So all we have to do is just select a particular region. So let's select our favorite region, US is one. And we have deployment options, right? So you should be very, very careful when setting these parameters, right? So you have maximum concurrent accounts and you have failure tolerance. So this just means that okay, that's just like it says, the number of accounts per region where you want to deploy your stack, right, at one time, right? So it's like okay, that I want to deploy for the sake of the demo, I'm going to deploy it across all my accounts and across all my regions, right? Then failure tolerance is okay in the event that this particular stack is not able to deploy in this particular region or this particular account, right? How many times can it fail, right, across multiple accounts or regions, right, before I completely stop this particular stack from creating? But for the sake of this, we're going to make that percentage 100. Then parallel. So we want our stacks to get deployed across across the regions at once, right, in parallel. Right, so that's why you have it. But since I'm just deploying in one region, so this doesn't really matter. So then we click on next, leave everything as default, and submit. For this to load. Great. So we have our operation running. And if you go to stack instances, right, you can see here that your this particular stack is running in this account, is running in this account as well in the region that is specified. So let's try to load and see how long this takes. It shouldn't take long, right? It's just a row. Let's say maximum 2 minutes or thereabouts. So let's just wait for that. So okay, succeeded, right? So our rows have been created in this full account. Right, the next stack set we want to create is stack sets that will create our access login buckets and our VPC free logs buckets. Right, so we have just like what we did, we upload a template file, right, and we have our template sitting right here, which is the bucket YAML. Open, yep. Then next, then we'll name this stack set custodian. Let's say custodian bucket, I guess. Next. We are deploying to the entire organization. So we'll do the same thing we did last time, right? But for the sake of this demo, right, you know that buckets are global resources, yes, but they are also region specific resource, right? Because if you create a bucket in a particular region, right, you cannot create that same bucket anywhere in the world, right? So in as much as we can access all the buckets from a single pane of glass, right? In as much as we say it's a globally available resource, it's still a region specific resource, right? So for the sake of this demo, we're only going to focus on one region as well, which is US is one right there. Then we change our deployment options percentage to 100. We change this to 100 as well. And parallel, just like I said, this doesn't really matter, right? Then next, nothing changes, all right? Then submit. Oh, good. So our buckets are being created. So let's give it some time. It might take it might take a bit longer than right. So while we are waiting for this to get done, right? So you might ask me that how do I ensure that this policy I'm creating, how do I ensure that I'm not doing something wrong? Right? And that's where dry run comes into play. Right. So what exactly is dry run? So you can create a policy and run a policy without actually implementing that policy. Right. You just want to know how many resources have been affected, right? Because it's just like when you run an SQL command now on your database and you see 9 million rows affected. I want like but I thought I just listed out something. How am I saying 9,000 9 million rows affected? Right. So in this kind of scenario now, you want to ensure that you know what you're doing, right? So that's why there's dry run there. It's just there to protect you from doing something you do intend to do, right? So let's see if our bucket has been created. Stack instances is still loading. Yeah, so our buckets have been created, right? So let's go straight into the video. So yeah, so now it's time for us to run our policies, right? So this is our policy here. So I really don't need to go back to explain what exactly this policy does. So I just go straight to run the policy. So when you want to run the policy, right? So since all our policies, so you can decide to have all your policies in different documents, right? So you can decide to have um policy YAML for enable bucket logging. You can decide to have another policy document for enable versioning. So I just decided to have those policies in one document. But per best practice, it would be nice to have all your policies in different files, right? So now when you want to run your policy now, right? From an organization point of view, right? You use CS7N org, right? If I want to run the policy per account, right? All I just need to do is to use custodian. But since I'm running org, right, that will be CS7 org, right? Then run. So let's do a dry run, right? So dry run. Um, we are going to reference our accounts. We want to deploy the policy to those accounts labeled there. Then we want our output file, that's the flag S. Then we want to reference our policy documents and what region are we deploying this policy to? Yeah. So CS7 org run. So this is a dry run. That means that you don't want any Lambda function to get created or you don't want any resource to get affected. So you might ask me, okay, that there are instances where you won't even have to create a Lambda function, right? That you need to run that policy point in time, right? So definitely all you have to do is just remove the part where you see mode, right? And whatever you do, right, it runs that policy at once, right? But issue about that is it's not scalable. Scalable in the sense, what if security is something that is continuous, right? Because a bucket is public, it doesn't mean, but because a bucket is not public today, doesn't mean the bucket will not be public tomorrow. So the whole essence of using a Lambda function is for um is for how do I explain it, for is to do something repeatedly, right? Constantly. Yeah. You want to be scanning your environment. If it sees a resource that is out of compliance, oh, I need to trigger this particular action, right? So dry run, yes. So let's run this command. So I think it takes about a minute to run. So we are going to wait for a minute or so. So let's just wait for that to get done. Right. So you can see that our output file has been created already. Right. But since we have 5 policies, right? So that means that we're going to have under output, we're going to have, let's say, 5 different folders. Um, yeah, I know I'm mentioning Lambda function a lot. So that's how special Lambda function is. I don't think AWS it does more than what you can see, right? So that function is very, very important AWS resource. So permit me for repeating Lambda functions, repeating it, right? But it is what it is, right? So let's wait for this for dry run to get done. Let's just check. Okay, yeah. So you can see that you have your tests account and you have your sandbox account. Take note that we omitted our management account. So you can see that all the policies folders have been created individually, right? So oh, test has been done, but sandbox has not been done yet. Let's look at, for instance, and let's look at this particular policy for VPC logs for the test account. So let's have a VPC in that particular account. So all you have to do is just to go to your resources.json, right? So you can see that we actually have a VPC in that account, right? But we don't have flow logs enabled, right? So this means that when we run our policy, right, we expect that this particular VPC is going to have VPC flow logs enabled. So resources.json gives you an overview as to the resources, right? So okay, that's done, right? So um let's go to our queue, right? So we have a queue here, right? And we have the queue, the encryption has already been enabled for the queue. So definitely our policy is not going to affect this. It's just one queue that we have in our tests accounts. So now that we are sure that we want to run this policy, then we can go ahead and run the policy, right? So we're going to remove dry run. Yeah, and we'll just wait for this to run. So what happens if I run this policy or I run this command and another person runs the command, let's say a week after, right? Will a new Lambda function get created? The answer is no. So what happens is it checks if the Lambda function has been created already with the same name, right? And he updates it. So let's say if in case, let's say I make a mistake with a particular policy now and I want to update it, right? All I need to do is just run this all I need to do is to update my policy documents, right? And run this command again. So what it does is it just helps to update the Lambda function, right? So it doesn't create a new set because definitely you can't have two resources with the same name, right? Because even resource name is also a tag, right? So you can't have two resources with the same name with an environment, right? And in the same region as well. So let's wait for this to get done and we'll navigate to our AWS environment and we'll verify. Let's see. Mm, So you can see here the resource counts, right? So this is a total of all the resources in those two accounts, right? So this just means that you have two flow logs, right? You have a flow log in US61 in account test, and you have a flow log in account sandbox, right? So our command is run. So let's move to our AWS account and let's verify. So let's go to, let's say, any minimal let's use sandbox, right? So let's see, or we can do the tooling, right? Yes, the tooling. So let's see, okay, if those lambda functions we actually created in those two accounts and in those two regions. Apologies for my network, but it's not my fault. So please, if you have any questions, just drop them in the chat. I'll definitely answer them when we are done. All right, so this is done. Okay, this is loaded already. Let's try, still loading. Yeah, so let's go to Lambda function. Let's go to a Lambda. Um, our account test is still loading, sadly. Let's see which is the first. Um, You'll need to unlock your iPhone first. Sorry, apologies for that. Then you go to Lambda for this. All right, US is one. Great. So you can see all the Lambda functions, right? Look at when the time was created, right? So if you notice, usually if I'm using config, I have to manually create those Lambda functions myself. But imagine having those Lambda functions get created without you having to write a single line of code, right? You don't have to start worrying about, oh, what Python library I want to use, something. So the same thing applies here as well. So we have our four or rather five Lambda functions. So every Lambda function that is created by a custodian, right? There's a name that is prefixed to it, custodian. So you can see that this function was not created by a custodian, so there's no custodian there. So it also helps you to track as well to say, oh, that this function was created by custodian. It's doing something custodian related, right? So let's look at a sample. Which one? Any, minimum, animal. Um, let's look at this flow logs, for example. Think well, let's look at this one for example. But we'll definitely test all the policies. That's fine. So I think we have enough time, I guess. But let's see. Instead of looking at it, let's just try to test. So let's create a VPC. Then let's create an S3 bucket. Then let's try to create an S3 instance. Let's try to create a queue, SQS. Great. Yep. So anyone that goes first. All right. So yes, it's one. Great. So if you navigate to logs, right, look at the bucket that we created, right? So this VPC already enabled fields for this bucket for this VPC. So let's try to delete and let's see what happens. Delete flow logs, delete. Right. So you can see here that we don't have flow logs here, right? So let's just wait and see what happens. So while we are waiting, let's try to create an instance or key, or let's see which one comes up first. Hmm. All of them are deciding not to come up. Queue, great. So we have this queue here, and if we go to our encryption, we see here that encryption is enabled, right? But let's imagine we disable the encryption now, right? So we disable and we save. So we don't have encryption enabled for this queue, right? So we're going to come back to it and let's see what happens. Let's go back to our VPC and let's see if okay. So let's give it some time. Let's go to our buckets, right? So remember that we created two buckets, yeah, VPC for log buckets and your access login bucket. So let's see if those buckets have version enabled because you know that we created them without version enabled, right? So let's look at the creation time, filter by creation time. Yeah, so let's look at this bucket here and let's go to the properties. You can see that we have version enabled. Perfect. Then let's scroll down to here. Then let's go to our demo logs buckets and let's see if you see we have version enabled as well, right? So that's that on versioning, right? So let's go to our VPC field logs and let's try to refresh. You can see here that field logs has been enabled as well, right? So this just means that your resources will be compliant as soon as they become non-compliant, depending on how many times you trigger a Lambda function or how frequently you trigger a Lambda function. So if I disable this a counting number of times, right, it's going to enable it back for me. So let's go to our queue. So we have validated how many? I think we have validated for um, VPC field logs. We have validated for versioning. Um, let's check our queue. Let's try to refresh and let's see if encryption is enabled for our queue. So encryption, yeah, right. Remember when we disable it now, it's encrypted back, right? So I validated for encryption, I validated for fuel log. So let's try to create an ES2 instance where the EBS1 is not encrypted. So create launch an instance. Yes, let's name this instance demo EC2. Um, we don't really need specify any. Let's just specify. Let's say Amazon Linux 23 T2 micro. But we don't really need a keyboard. Nonetheless, um, we don't need. Well, even though we do this, right? That's really non. So, and details. Right. So let us we want to encrypt our volume, right? We don't want to use a volume that is, well, looking at this, right? We are not enabling encryption for our EBS volume, right? So if you go to advanced, right, or click on this, yeah. So you can see here that we don't have any, you can see encrypted, not encrypted, right? So ideally this EC2 instance should get terminated upon creation because our volume is not encrypted. So let's leave everything as default and let's try to launch instance. So the same thing that happens there will also happen in your other account as well. But because of time, I'm not going to log into the other account and tests. But let's just try and validate all our 5 policies. I think it means two. So let's see. It is loading. You can see here that it's shutting down already, right? So that means that this EC2 instance was shut down because we didn't have EBS volume encryption enabled, right? So for the last, I think the last one should be access login. So let's, I think we can use this demo bucket to verify. All right, so or rather, let's just create a new bucket and test it. Let's see. So, um, let's see. So let's say we name this demo. Let's say AWS virtually disabled. Right. I'm not going to enable, so create buckets. All right. So we're going to wait for this. But let's just try and do something. So we have validated all our policies aside the access login. I will definitely come back to it. But let's just go back to our slide and continue. So there are three major takeaways, right? The fact that Cloud Custodian provides you real-time automated guardrails at scale. So you can see how we implemented Cloud Custodian across all our accounts, right? And we picked a sample region, right? And it also helps you reduce cost. So imagine if you have multiple instances that were forgotten, right? Because take notes that even though your resource or even though your history instance is shut down, right? It's still going to collect AWS is still going to collect money from you, right? Until it's terminated. Right? And also continuous compliance. Just like I said earlier, compliance doesn't include the security, right? Because you tick a particular compliance checkbox, or because your AWS account is compliant to a particular framework, ISO, SOC 2, PCI DSS, and all, right? Doesn't mean that your environment is secured from threats, right? Compliance is continuous, right? You need to ensure that all the resources in the environment are continuously checked for different misconfigurations or different non-compliant resources and all. So I think that's the end. I think that's the end of my slide. So I will stop sharing now. Um, thank you. Let me know if, yeah, I think I'll start sharing my screen. Yeah, thank you. All right, so I think I'm done. So let me know if you have any questions. Or
Thank you very much, Mr. Ore. So now we're going to be moving to the Q&A section. We have heard a lot from Oreoluwa, and I know some of you have questions. So if you have not, please go ahead and drop your question in the chat. We're picking a few to answer, and our speaker will answer as many as he can. So let's see. I'm not seeing your questions yet. Please kindly drop your questions in the chat. Oh, are you guys saying that you fully understand what Mr. Ore said?
that would be nice.
Ah. Amarachi said, "Thank you, Mr. Ore."
You're
Thank you,
welcome, Marachi.
Tamarachi. Thank you for joining. Debbie is giving you a round of applause. We are still waiting for your questions. We don't really have so much time anymore. Mr. Israel said, "Well done on a great demo. Thank you." Ah, people will not thank me too.
Okay, I think if we don't have any question, then we can definitely move to the gaming session. What do you think?
Okay.
Or should we
So
wait?
maybe I think we can move to the quiz session. Maybe after the quiz session, we would have some questions. Maybe they are still thinking about it.
All right, sure, that's fine.
So we can start the quiz session now. So while we move to the quiz session, please feel free to drop your questions in the chat. We'll take it after the quiz session. And in this quiz session, please bring in your A games because if you have been joining our series, you would know that the winner gets a prize, and it can be you. Okay, if you go to the chat, you'd see a link. So the leads you to the quiz. So you can just click on the link and you can start the quiz session. Okay. We are still waiting for players to join, and we currently have 0 players. Are you guys having issues with joining the link? Or let me know. I think it's working. Or would you prefer I keep the price to myself? I'll be happy to. Okay. Okay, we have 3 players already. Okay, 4 players. Oh, now you guys are awake. Thank you and welcome. Oh, someone just dropped. Okay, we need just one more person, then we can start. We currently have 4 players, so just one more. And it can be two, it can be 10. But when we get to 5 players, I'm going to start. Okay. So we have 6 players. So I think we can start now. So our first question says when writing a cloud custodian policy that triggers. Okay, so we have less than 10 seconds to answer the next question. 3, 2, 1. Good. So we can move to. Oh, 3 people got the question correctly. So the answer to which language is used to define policies in cloud custodian? The answer is YAML. So we can move to the next question. Oh, currently Bell is leading, followed closely by Atom, then Janet. Olajide and Kelechi, are you guys playing at all? Okay, for the next question, we also have 24 seconds, less than 20 seconds to play. It says Cloud Custodian can automatically remediate non-compliant resource by integrating with which AWS service? If you're listening during the session, then this question is supposed to be because I already know the answer. Yes. Wow. So who picked EC2? Okay, the correct answer is Lambda, and our speaker explained it well, and he even did a demonstration. So I think you guys need to like rewatch the session. So currently, Atom is leading. You took Bell, and Bell is leading second place. The next question is: what is the purpose of the die run option in Cloud Custodian? I know the answer to this one because I was listening. We would know how many people were listening during the session. So let's see our answers and see how many people got it correctly. Yes. To test policies without making changes. So if you're not ready to make changes to your environment, you can use the dry run option to test the policies. So let's see. Wow, Atom is still leading, followed closely by Bell. Blair, what is happening? Are you still here with us? So our next question is: can Cloud Custodian manage resources across multiple AWS accounts? So we have yes using C7N dash org. No, it only works within a single account. Only work with AWS organization. Only with third party tools. So let's see our answer. Only two people got it. So the answer is yes, using the C7N dash organization. And currently we still have Atom. Oh, up now, but Atom is currently leading. So we can move to the next question. By the way, you can still drop your questions in the chat box if you have questions for our speaker before we end the session. So the next question says, when writing a cloud custodian policy that triggers on AWS config event, which of the following is required for real-time compliance enforcement? Wow, everybody. Is that everybody? Yes, everybody got the answer correctly. I'm so proud of you people. I'm sure you guys are really listening. So Atom is leading. Oh, our winner is Atom. Congratulations. Please kindly reach out to us and get your prize. So we still don't have any questions in the chat box. Is there nothing like you guys don't have any clarifications, any questions? Or we are all fine, we are all good. We understand perfectly. Okay. Okay. Okay, so before we end the session, I would be inviting
Yeah,
Mr. Oreoluwa back to.
yeah. Hi, Motun. So there was remaining one policy that we didn't verify and validate, which was the login, right?
Okay.
So let's check and see if our buckets have been. Let's look at these buckets demo AWS. All right, and let's verify if bucket login has been enabled. Um, access log. Oh, it's showing disabled, but that's okay. So let's just see what's wrong, right? That's the entire purpose of troubleshooting, right? There are instances where something doesn't go as expected, but we can see what's wrong and we can try to remediate the solution. So let's go to our enable bucket login. This is the Lambda function that enables bucket login. Oh, I thought I was sharing. Am I sharing my screen?
No, we can only see
Oh, really?
you.
Oops. Sorry, I thought I was sharing my screen. Sorry about that. I was saying that our bucket login is still not enabled, right? So wondering why, but let's see what's happening. So let's go to our Lambda function that enables bucket login, which is right here, and let us go to view CloudWatch logs and let's see. Let's see what's wrong. Let's see what's wrong. So while this is loading, let's just inspect our Lambda function, the code. So under code, I think network is quite slow today. Okay, so let's inspect. Oh, okay. So let's review the logs. So it says here, error modifying buckets. Since specified bucket is not valid. I think I see what's wrong. So I think the target bucket that we specified is not valid. Let's see. Let's go back to our lambda function and let's check. I think not sure why my screen froze, but let's see. Let's just go. Let's just inspect our policy bucket login. Yeah, yeah. This is where the issue is. So this is not a. Let me increase my. Let me. So this is not a cloud formation template. So this is not going to work. All right. So we have to replace it with account underscore ID. All right. Great. So save. Yeah. So demo blah blah account underscore ID. Yeah. Toggle login. Yes. Great. So take note that we're going to run the policy again, but this is just going to update the policy. All right. So let's run it again and update. Right, so let's wait for this to load. While this is running, all right, let's validate. Let's see this network is quite bad today. Got us load. Our policy is run then. We can now try to revive. Let's see if this loads on time. This is going to the browser is blocking the line. Browser sandbox. It needs to blah. Check illustrator. Not sure what's going on, but nonetheless, okay. So it says process pool. So the process in the process pool was terminated abruptly while the feature was running or pending. Error running policy in test. Process in the process pool. Alright. So let's try to run this again. Let's try to let's try and update our account, right? Let's try and update our credits. Okay, I think it's trying to, but nonetheless, let's try to refresh. Alrighty. So get our concretes. Then let's change set our credentials. Okay, great. So if you go to our config JSON, right, you can't, yeah, right. So this is not going to work, right? So let's go back and try and run our policy. Yep, I've already updated my credentials. So let's see. But ultimately, what this is going to do is going to update the Lambda function, right? And it's going to change what you changed, right? So take for instance, now we changed our login, right? So that's what this is going to do, right? It's going to change the access login bucket to ensure that okay, that is the correct bucket that the login is being pushed to. So I think I'm done. Thank you, AWS community, for the privilege. So let me just stop sharing my screen. Yeah, Motunrayo, thank you very much.
Okay, thank you very much to you, to Mr. Ore. So the winner can send a mail to our email address. I don't know if you saw it. Okay, yes, the link is showing on the screen now. So Kelechi said, I just saw this randomly on YouTube and joined. Is there a closed group outside of YouTube? I would like to join. Yes, there's a group outside of YouTube. It is not closed, it is open for everybody. So you can go to the link tree link on the screen and you would find a way to join our group. And you're welcome, John Carroll from Lagos, Nigeria. We're done with this session, but you can watch back and play it. And so, just like that, we have come to the end of today's session. And a huge thank you once again to our speaker, Mr. Oreoluwa, for the insightful and practical walkthrough of Cloud Custodian and how we can enforce AWS compliance at scale. So, I'm sure if you're really listening and you're looking for real world gems, by now your notebook should be full. So to everyone who turned up for this live, thank you for spending your time with us and for engaging in the chat, and thank you for being part of the community. And please don't go ghost. The series continues. Next week, we're going to be back with another powerful session titled Securing Data Sharing with AWS Transfer and S3. There, you will get to explore how to move data securely across environments using AWS native tools. And trust me, it is also going to be very insightful. So make sure you are subscribed and turn on your notification. And don't forget to invite your team, your friends, and everybody that is trying to get into tech. So until next time, stay curious, stay building, and stay secure. I am Motunrayo Sanusi, and it's been an honor moderating today's session. Thank you.